So welcome, this is Space Data Hackers. We are here for the March 27th version. I'm Eric Veal. I'll be hosting and kind of guiding and facilitating tonight. And we also have Tom Riecken, who you can see on camera. He'll be our main presenter today. And then Mike Doyle's here helping me pull this off. This is Mike's show originally, and I've recently gotten involved in just helping with organizing and getting people in the door and just trying to run everything. And so that's been a lot of fun. So welcome to everybody that came tonight. Just a few kind of announcements, and then we'll get over to Tom pretty quickly here. So first of all, our topic tonight is, wait, what is space data actually? And so my brief intro on this is, I think this has probably been a question that I've asked, is like, what is Space Data Hackers? I met Mike through a friend, and I liked the name. I come from a data background. I've been working in the business intelligence space since about 2010, or maybe a little bit earlier than that, and worked at Tableau. And so data is a great word, and learning more and more about space, but space to me is kind of intimidating of just how broad it is and whatnot. So I think this is going to be a great talk tonight to just kind of understand the domain and categories and just like what really is in this bucket. So I'm very excited about that. And again, we've got Tom with us tonight, and I'll hand it over to him in just a little bit. And here's kind of the plug. You guys probably saw it before you signed up, but he's going to lead us through a talk about what really is space data. It's not just data from satellites, so more than that data stream. So explore the data and its domains and categories, and then he's going to walk us through a day in the life about people working in space and what it's like to do that. And then hopefully we can imagine in our own cases how we can use our skills, et cetera, how they might fit into this broader industry. Quickly about Tom, he's been working with space data for a couple decades now. He's got a diverse career throughout across astronomy, aerospace, and BI. He and I were just talking about Microsoft. I've got about 8 years of experience out at Microsoft now, and data warehousing. So just, again, like whether it's data generally or data specifically, Tom's covered those topics. And so just kind of an interesting perspective on systems and info and how it relates to people ultimately. And then he's also been very actively involved in space apps, and maybe he can tell us a little bit more about some of that. And now over to Tom. Welcome.
All right, thanks very much, Eric.
Yeah.
And, seen a few familiar faces on here too. Okay. Perfect. All right. So, what is space data? Yeah, this is going to be a wide talk, a little bit shallow, but very topical. Very much, covering a lot of breadth, but not going super deep. And that's intentional, and hopefully this will help us, Space Data Hackers, as a meetup group, as an organization, start to organize our speakers a little bit. Awesome. All right. So our agenda. Appreciate Eric's introduction on me. I'll go in a little more depth there. Then we'll dive in. We'll talk about data domains, categories, what are the different buckets of space data? What are some examples? How do we describe them? We'll talk briefly about modalities, so different ways you might interact with those different categories of data. Then we'll take a detour to talk about personas and examples. What does a day in the life look like for professionals of various stripes? Tending to be in one of these domains or another, but there's always crossover. We'll talk briefly about technology and platforms, so just on what is the what should be your ethos for picking the right tool. And then lastly, I don't have a lot on where to go learn next, but it'll be a call to action to start compiling some of those resources. Awesome. All right. Might have gotten a little carried away with the animations here. All right, so who am I? I've been space geek since childhood, building a lot of model rockets and playing with telescopes and being part of the astronomy club at my high school, and then transitioning to physics and astronomy study at the University of Washington. So I jumped right in when I joined in my undergrad, looking for using Hubble data to look for exoplanets, and then we had what was called the Sloan Digital Sky Survey, which is this big academic data set, surveys about a quarter of the whole sky. So a lot of data mining projects came out of that for me and my cohort. So they would look for things like cataclysmic variables and planetary nebula, and all, colleagues look for all sorts of fun things. So that's why I first got introduced to SQL and Python and more esoteric languages that astronomers use. And a lot of that's probably pretty dated. Then transitioning to career in data analytics in the Seattle area. Talking to Eric earlier, just my early grind, my early career was contracting at a couple of shops, including Microsoft and Amazon and a few other places. And then I first got involved with NASA Space App Challenge, which is a big thing that Space Northwest coordinates every year. Back in 2014, long before Space Northwest, I think that was the first year in the Seattle area. I ran it the year after, but for 2014, I pulled together a team, and our project did pretty well. We ended up applying to this group called Space Gambit, and then we pulled together a company. I can give a talk on that sometime. How we were going about modeling a space economy and doing after dynamics. So some really interesting technical challenges were part of that project, and also, just understanding the complexity of game engines was almost as hard as the physics we were doing. So maybe that'll be a future talk. More recently, I've worked at the University of Washington in the Earth Space Science Department in their administration, then transitioned to Blue Origin, which I have a few colleagues from there here. So hello. And transitioned from an analyst to a product manager there during a period of huge growth. Currently, I'm at RTX, formerly known as Riecken Technologies, which is a massive company. So a lot of good growth there as well. I'll highlight this talk is unaffiliated to any current and past employers. It's educational focused in its nature. It's non-technical, unrelated to my work. And a bit about me beyond the professional side, supporting Space Northwest and sort of paraprofessional work. Being a dad, I have a 1.5-year-old. He's great. Runs me down. Gardening, fishing, hiking, drumming poorly. I'm working on a few novels and nonfiction books. And then I'm literally Batman. I think most of you know me. I'll touch on that towards the end and why it's relevant to this talk in Space Northwest. Let's dive in. So I've sorted things into these 4 buckets. When we think about space data, or when I think about space data, these are the 4 overarching buckets or categories, domains for all intent and purpose, although domains can be an overloaded term. So just a logical way to sort data and to sort, the phenomenon that we're trying to describe as space data. And of course, it'd be fun to have this kind of be a growing, evolving thing. But this is just kind of a place to start. So we'll touch on business data. We'll touch on situational data. We'll touch on observational and communication. And every company and organization out there is going to be a little bit different. There's going to be overlap, which is why why I had it wiggling here, to show that these are flexible boundaries, and what is business data to one company might not be business data to another based on what that business is doing. So bear that in mind as we walk through the different categories. All right, so business data, also sometimes called enterprise data. There's a lot that goes in. There's a lot of data out there that is associated to how your business runs. It would be common to any company. So there's business data that every single company out there is going to have, things like finance and human resources. Then there's things that are going to be specific to manufacturing companies or specific to engineering companies, and then companies that do all of that and more. They're going to have aerospace companies, big aerospace companies. They're going to have a breadth of things. It'll look similar from aerospace company to aerospace company. Very similar concepts, very similar data. It's always about taking things from requirements to engineering to manufacturing to operations. That's as deep as I'll go on that. But there's this breadth of how aerospace companies operate and the types of data that they look at. So I would roll that into business data in terms of thinking about that as, in particular, space data. And the tools and types of tools that are used for that tend to be on the cloud. You tend to be looking at building on a platform. On the right is just a sketch of some of the services, cloud provider agnostic, showing all the common players in the game. So I think this is fairly straightforward. People want to dive into this further later, we can go into it a little bit. But every company has their secret sauce, and it's always going to be something to keep the trade secret. Situational data. So this is, are you tracking assets, hardware in real time? In the example here, I have TLE or two-line elements. So that's like the type of data you would use to keep track of a satellite. But that's just one example. You can have data coming off of a rocket that gets launched. You can have data that's about the control of the satellite. You can have data about command and control of a rover on Mars. You could be NASA data. They're looking at astronaut biometrics. So just anything where you have assets in operation. I think what constituted as space data is that your assets are not on the planet, or they're linked to things that are not on the planet. So this is really just keeping track of what you have. And common tools might be MATLAB and Simulink. I think those. I don't think the number. There are more vendors than that, of course, but it's not as broad as the general data science and data engineering that you would typically see for business data, because this is a narrower market.
Tom, can you say again what TLE stands for, please?
Yeah, that's two-line element. So like if you want to plot out using a Keplerian coordinate system, your apogee, your apogee, your perigee. So you have an ellipse. How do you define the ellipse for the motion of the satellite?
Gotcha. Thank you.
Yep, no problem. All right, so observational data. So this is the other two are very broad. This one is also very broad because this covers all of astronomy and all of Earth observation. You're typically going to be thinking about sensors and what part of the spectrum are you using. You might be doing multiple signals, so combining signals to make your analysis. In astronomy, there's a lot of work that gets put into building these giant catalogs. For Earth observation, there's very similar. You pay to get access, and you have all this geodetic information that you can get into. So this is as broad as all of astronomy, all terrestrial observation, all observation of other planets. I would say typically most of this is going to be considered remote sensing. So yeah, this is a huge domain, extremely varied, and we'll touch on touch on this a little bit in the personas in a minute here too. So, all right, communication data. Admittedly, this is where I have the least working knowledge or experience. So instead of keeping track of the satellite, this is what you're using the satellite to do. So if you think about Starlink or Amazon Kuiper, it's the packets that you're sending, and the customer using that, is either broadcast or bidirectional. So if you were to set up a UHF receiver and or VHF receiver and get weather data, off of, I can't remember the name of the constellation out there, that would constitute this. But so would just having internet provided by satellite. So it's the activity of providing that communication and network and the content that sits within it is what I would consider to be communication data. Yeah, and a lot goes into there's a lot of overlap with the situational category for that category. So giving it an all-up view, these are kind of the broad overarching categories. And then here is not by any means an exhaustive list of subcategories. So, on the business side, you have that full spectrum from finance and program to manufacturing, service lifecycle, people and talent. Situational, you might have things that are as mundane as running a procedure on a test, all the way to keeping track of the health and biometrics that you're asking on. So that's a broad category too. Observation, really, as I was stating before, has those two major subcategories, being astronomical and geospatial. So geospatial is going to contain the entirety of GIS as a practice, and then of course astronomy is extremely varied based on whether you're doing radio versus infrared versus X-ray, satellite based versus ground based. It's a huge, just as huge as everything else here. Communication, these categories need the most work, but I think I would say in mass broadcast versus internet, maybe GPS gets put into this category. You could look at you could look at ways to increase security. So that's certainly something that might fall into that category. And then of course every one of these categories kind of has its own associated overarching themes. So business data, you talk about digital thread. Situational is digital twin. For observation, there's like a digital earth and sky out there. I think Google has. There's a lot of really big buzzwords that kind of associate to each of those categories. I think as more talks are lined up for space data hackers, it'd be interesting to see where the cards fall in terms of where they line up. Okay, great. So this is the modalities. So on the left is kind of the same categories for me. On the right is kind of looking at things in these different dynamics. So non-real time, it's not. This is a broader sense than just purely analytical. There's near real time, which is again more broad than just transactional, and then there's simulated, so stuff that doesn't exist or could potentially exist. I differentiate that from the analytical because it's I would say the analytical stuff is real, it's actual, it's happening. With business for analytical purposes, like that's traditionally where you're going to see all your dashboard work. I think Eric was saying he worked for Tableau, so that's their market there. Situational analytical is potentially looking at engineering after action reports or things of that nature. Observational is a bunch of scientists getting together after they've done a observation campaign and writing a paper. So most of the observational data is when in the analytical space is going to be either sciences or there's non-real time other trend-oriented Earth observation use cases. Communications domain, so that's going to be modeling and or looking at your performance of your network over time. For near real time for business, that's making sure your software is well stitched together. Information flows from one to the next seamlessly. Situational would be this is probably more common for the situational domain. It's where you're actually looking at events as they unfold. Observational is so I guess we're talking about I forget if you said it was blue water, blue earth, or I forget what you're saying that category was, but blue tech. There you go. Mostly in this area, it's going to be military use cases for tracking things in real time, but that's not entirely true. Agriculture, blue tech, you might be observing fishing fleets that are out there, making sure folks are staying in, legal. Fishermen are both are staying in the right legal areas that they're supposed to. Communications domain, that is the actual link management. So making sure that your sessions are open, that your network is running. So there's probably a lot of tests baked into that. Then over here on the simulated category, so within the business context, you might be doing scenario planning or simulation-based engineering, things of that nature. You'd be focused on how do you test your decision before you spend a lot of money to make that decision. Situational, you might be looking at testing hardware, software in loop. You might be doing orbit propagation. There'll be a example in a little bit. You might be doing short-term forecasting, so all weather prediction, I would say, kind of falls into this category. And then for observational, you might be doing climate pattern modeling, or you might, if it's in astronomy, I had colleagues in school who did a lot of n-body gravity simulation. So there's a lot of different things you can model stochastically and then test it against what's actually observed from a survey. And then for communications across the simulated, you might have like a workbench, or you might be planning your constellation out, right? So how will you make sure you get the spread that you are planning to have, the coverage that you want. If anybody has any questions before we dive into the next section with personas, we can take a few. Otherwise, take note and we'll come back in.
Any questions for Tom?
Yeah, go ahead.
Oh, no, sorry. I just said any questions for Tom. Just trying to facilitate a little.
Awesome. All right. We can always come back. Yeah. Sorry, jump to the right one. All right. Personas. So, how do all those categories and modalities apply to people? How do we represent that in a approachable and humanistic way? And below is a picture from NASA Space Apps. Mike in the corner there, Sean McClinton on the other side, and really just showing the spread of the unique sets of people and ideas that come together, and all the different life journeys that all culminate into one area, which is doing really cool stuff, working with data for the intent of the betterment of people in space. That's why Space Apps is so amazing. And I think it's empowering. I tell my family, I call it space church, like space Christmas. All right, so with that, we'll dive in and we'll touch base on kind of a couple not real people, but representative of real people that I've met over the years, and what do their lives look like in the context of space data, and in particular those categories we just talked about. All right, so this is Sally. She's a postdoc studying planetary nebula. Finished her PhD, but she's continuing to do research at the university while she's looking for a tenured position somewhere else. So her work is all centered around observing real planetary nebula and then modeling using EHD. I don't know the actual plasma hydrodynamics simulations to try to reconstruct the nebula and how it took shape. And so her life will constitute using these large observatories. For example, that one was Keck on Mauna Kea in Hawaii. There's some images of a planetary nebula. In astronomy, there's this whole process of what's called flat fielding or reducing your images. It's not as much. It is a science. You can do it in an artful way. I know a few folks who have some good stories on that. But yeah, so and then on the right, she's doing these simulations. She's probably that might be written directly in C++ for performance reasons. But there's also a lot of old legacy code floating around in academia, so it could just as easily be written in Fortran. But she's doing image reduction, statistical modeling. She's writing papers and lecturing classes, and that's what her day-to-day looks like. So she is a space data hacker, and she falls into the astronomy category, and she covers both the the observational analytical and then the observational simulated modalities. All right, so this is mission engineer persona. This is Finn, who works for a Mars rover program. And take a moment to note how unfortunate it is about JPL. I know there's some layoffs there in the last few months. So Finn, he came out of an engineering school. He has a background in both mechanical and electrical engineering. When he was at school, he worked on like a motorsports program to build race cars, but then managed to find an internship working for a Mars rover. It could be like ASU, for example. They worked on the Phoenix. And so he put in a lot of hard years, and eventually he was able to join the control systems team. So now he works at hypothetical place where they control rovers. He spends a lot of time debugging MATLAB and actually controlling the voltage that turns the wheel of a rover on another planet. And so he needs to be able to coordinate between that and what they're actually getting back from the sensors and the positioning and the LiDAR and stuff. So really he's charting out how this rover moves across the surface of another planet, and then maybe he works with a close colleague who controls the instrumentation. So his day is spent making sure that the scientists and the other engineers on this team are able to get what they want from having the rover in the right place. So he's got so his category is real time, and it is situational. But it's not only that. He also has a lot of simulated work where he simulates the maneuver before taking place. He'll consult with maybe weather data as well. And then he's using positional data, various stored constructed from observations that the instruments have made. It's a very complicated set of categories, but primarily to keep track and keep the rover in the right spot. All right. So this is a satellite tracker persona. We'll call him Hamid. He works in constellation management. So space situational awareness is a large and growing market. There's a lot of competitors out there. There's a mix of tools that help with display as well as predicting the location of where those assets might go. So for his background, he's Air Force veteran. It's where he learned most of the skills. He's well versed in tracking satellites and inferring their positions. He can think in Keplerian orbits. He works from home. He's works on algorithms that can deal with the telemetry, and then he's potentially doing machine learning to predict where those collisions might take place. So he has an algorithm, or he has a trained model that can make inferred judgments about potential risk of satellites that might collide. So his company has both civil and defense customers, domestic, international. The goal is to make sure that satellites aren't hitting other satellites. So he simulates his work, he backtests his work, and then a lot of it is kind of mixed between analytical and real time. I think nothing should ever get to the point where real time decisions in under a couple minutes need to take place, but there's news articles out there that has almost been the case. So yeah, real interesting way to paint this picture. Yeah, I think it's that type of space data. I don't know if we have any speakers lined up, but could be very interesting to see someone give a talk on that topic. All right, so software integration persona. So this is CAM. They work in enterprise data. CAM has a background in computer science, began as a contractor. They worked their way up through different companies, or finding a position in a new space company, could be any size. So started off in the business world, transitioned to aerospace. They do a mix of data engineering, software engineering, real-time data management. So continuous integration is something that CAM deals with a lot. So all the things that are common to DevOps. They have a favorite IDE and strong opinions on linting. I know plenty of data engineers who do. So yeah, this is CAM's world, typical office job, but they are supporting the mission of infrastructure in space. So it's important to know that it's important part of what's considered space data. So with all those personas in mind, where I would talk about tools, so I will say we're not going to talk about tools. There are tools out there that generate data. There are tools out there that help manage or move data. There are tools out there that help make sense of data, and they all depend on which of those categories you might be looking. You might line up with. Every single persona out there probably uses Excel for something. People don't want to admit it. It's a love-hate relationship. But whether it's just keeping track of work or whether it's part of the day-to-day, it's pretty common. But yeah, I think the point I'm trying to make here is there's a lot of tools and systems out there, and it's going to change every 6 months, and maybe even every other month. And as Space Data Hackers has more talks, be interesting to take note of what background they come from, what category and what sub industry they're in, and what tools they talk about, because it can be pretty broad. So yeah, there's data generation. There's tools that are more on the engineering side that are really focused on data management, and that there's tools that are in manufacturing that are more focused on data management. There's tools for managing satellites that are more that have aspects of data management, and then there's the general data tools and cloud management tools that are common to every single business. So without talking about the technical of what those things are, just taking note that it's a big playing field, and it just takes time to learn where you're going to work. So with that as context, for any new folks out there interested in these types of careers, it's important to realize there's stuff that you can do on your personal device, and there's stuff that you need to be part of a large organization to take advantage of, that I would call platform. So for hackathons, for personal experiments, unless you're building your own, Beowulf cluster, or you have your own server rack, you're probably going to be doing things on a single device, or maybe you have a couple of cloud assets, but you don't have an unlimited pocketbook. You can't justify a couple thousand in AWS spend. So you're doing it on your local machine mostly, maybe with a few exceptions. And if you're brand new, you should just go install Anaconda and come up with some projects to work on and find a class to go enroll into. So that's where you'll get started. And as you get better with that, being open to learning more and taking advantage of the platforms that are out there through the various organizations, whether it's through a school program or through an internship or at your job, or wherever you may be. So just start small, grow from there. All right. So yeah, like I said, the last thing on here is where to start to learn. And I tried to come up with categories for this one too. What I would say is, I think we should have a call to action where Space Data Hackers could start compiling. I don't know if Space Northwest has a good area on its webpage. It might be good to start storing some of these, or just like a list in GitHub somewhere. But I'd broadly organize things into self-learning, academic study, and then professional and education organizations. So on the left-hand side could just be you on Coursera or even YouTube. Could be starting a project, just learning as you go. For academic study, if any high schoolers ever watch this, as you join the university, be selective in the classes you pick, and work with your guidance counselor on what to pursue. And then continuing education. We have Kevin Anderson on here. He's a continuing education lecturer at UW-Tacoma. So there are many programs out there that are worth pursuing. There are outreach events, so like job fairs or sometimes even more technical events that'll be affiliated with educational venues. And then, for professional organizations, there's meetup and professional groups. So this one, but also many of the other offerings that Space Northwest has. There's other groups like PNAA and a couple, and other professional organizations that will have similar reoccurring sessions. I put hackathons into that category. They might overlap with the academic in some cases. A lot of colleges will have hackathons internal, and then just generally conferences and events. If you can get to, we were talking Microsoft earlier. I haven't I haven't looked at Tech Ready in a while. I don't know if that's still going on, but things of that nature. So I think it'd be really cool for us to start compiling a set of resources in these categories or categories like this. I think that'd be a really strong thing. That if there's one out there already, let me know.
Yeah, actually, Tom, there is a Space Data Hackers GitHub with a wiki. Just plop the link to that. And you can always find that by going to spacedatahackers.com.
Yeah.
And just click on wiki.
Cool. Yeah, look into that. I have some old repos I could probably even throw in there from that project I was talking about earlier. Awesome. All right. Lastly, I told you I'm Batman. So for those of you who don't know me, I bought a house a year ago, and on Whidbey Island, it turned out to be infested with bats. Somehow that got missed or intentionally downplayed in the inspection. So I've been working to remediate that since about December. I had to wait the bats out. They all migrated away for the winter. I share this with this group because one thing that I'd like to do in the long term is, after it's been fully restored, is to host getaways. And so we'll have a couple different rooms that people can rent, and just kind of have these retreats where people can come and work on projects, and we can nerd out on science and data, space data, and whatever else. So yeah, I will keep sharing that out with the space data community for those who are interested. And then the other connection to bats is space bats. So back in 2009, a Mexican free-tailed bat landed on the shuttle, or landed on the main fuel tank of Shuttle Endeavour, and presumably did not survive the ensuing blast and launch to space, but the memes have forever memorialized him. And yeah, some really good content out there if you look into it. So maybe at some point I will host a space bat weekend or something. So on that note, Finn, all wrapped up. Let's see. Oh, Mike was just putting the link in the chat. So yeah, any questions, comments, witty remarks?
Thank you.
Yeah, thanks, Tom. That was a very exhaustive, broad stroke of all things space data related. The slide of all of the tools just gives me heartburn, right? As an architect, having to decide what all of the right tools are for teams to do their analysis. Like, all of those tools have pros and cons, right? And they have different purposes, and having them all work together, it just speaks directly to my persona of trying to put all these things together.
Yeah.
And you're right, Excel is the best engineering tool there is. It's everywhere.
Right. Yeah, I think I know our NDAs restrict us from going into depth, but I think it would be cool to know. Be cool if there are any account managers from any of these tools who give routine talks, and yeah, it's certainly, I think the other thing to add to that, Kevin, might be just the number of people who reach out. I don't know if you get the messages on LinkedIn, and every company out there has the golden ticket solution that's going to solve all your problems.
Of course.
And then at first, and then the executives, I'll buy in, but no one who's been in the profession long enough is that naive. So that's always the perpetual fight.
Yeah, scrutinize everything.
Exactly.
That's what science is all about, right?
Yep. Yeah, I love that space data is such a mix of the business world, science world, you know, geodetic and mapping and kind of, I don't know what you call that. It's the civil and even the defense world. So it's a lot of sectors that really depend on the space data. So yeah, it'd be interesting to see how we develop the speakers list for the years to come. All right. Anything else before I hand it back to Mike or Eric?
I have another
Thank you, Tom, for that
question, but
talk.
I want to give others a chance to ask before I bombard the.
Yeah, go. Someone was speaking besides Kevin.
Yeah.
Are you done?
Oh, go ahead.
Yeah, I'll just keep mine brief. I just want to say thank you for that talk, Tom, and I really appreciate the detail and the thought that you put into your slides. And if we ever have updates on when to get together at your places, I'd be glad to drive up there and be cool to meet you in person and get together at your bat and breakfast.
Yeah, probably be a year. In the meanwhile, I should have created a slide that has a link for the Space Happy Hour that's hosted by Craig Berdewald. If I pronounce that right. So there's actually one happening tomorrow. I can't make that one, but they happen every month. So those are a good fix until I can host retreats. Kat,
Yeah. Well, this has been really, really enlightening to me. So thank you. Thank you for this. I do have a question, and it might be kind of basic, but my knowledge and experience has primarily been in space hardware, product engineering, and manufacturing in the business category that you described. And you mentioned digital threads in a couple of places here, the business bucket and the data modalities. From your perspective, or anyone here, can a digital thread incorporate data from multiple of these modalities you described, or do you think it's exclusively contained within each?
I mean, no. I mean, yes. Digital thread can be whatever you want it to be. But I can't really talk about how I've seen it, like technically deployed. And there are different modeling there are different architecture you can use for how you want to do a digital thread, and that's all trade secret stuff, either at Blue or where I'm at now. But
yeah,
certainly it can bleed into the other spaces for sure. And it's gonna depend, like, a satellite, like a planet or a Leo Stella or a Maxar is going to be very different from a Blue or a SpaceX or a Boeing. So, yeah, I mean, these are really just kind of I'm really just trying to highlight here that they're buzzwords that you might associate, but they're going to be loose to each of these categories, but they're going to be loosely associated and overlapping for sure.
got it. Got it. Thank you.
Kevin, you had a personal. You said a personal question.
Yeah. On the modality slide, I thought you might speak for a minute or two on the different shapes of the data that fall into these categories, or like some are nice and easy rectangular data like CSVs, some are time series versus shaped like nested objects in JSON, but there's also proprietary NASA formats that are in entirely different shape. Just curious if you wanted to give a couple of minutes talking about the various formats.
Yeah, that comes up every NASA Space Apps Challenge. Like all the challenges have these like esoteric formats, and they're almost always different. When I did astronomy, I was always trained like there's .fits files, So that's kind of like a raw image format. I don't know if it's common outside of astronomy, but for any like CCD or charge coupled device type camera, that's what like most instrumentation I worked with was. But then NASA has their own, like, it's every mission seems to develop their own approach, and I think it might be good to get someone from NASA who's worked on one of those missions, because they might have constraints with sending that data, like trying to get it over the wire from remote parts of the solar system. So I suspect that that's what's at play, but you're right. It's like the shape of data like that. So that would be like, kind of in this, one of these categories, kind of between those two categories. And even the simulated stuff can be kind of weird. But it's all about, compression. Like clearly, compression is a concern for any of these modalities. So, I think in astronomical data, the headers are really big, which I don't know. Business data, I think you usually have like a map, or you have that, any metadata you need somewhere else. Not always, but yeah, I guess that's my experience. And on the communication side, like, I know absolutely nothing, but I assume, some of that stuff down at the protocol level. And so, yeah, there's probably every box on here has not only one shape, but could potentially have hundreds of different shapes and styles of data.
Mhm.
Totally.
Another reason why there's so many tools to analyze it.
Right, but it's all going to get fed into AI, and AI will interpret all of it perfectly with no problems whatsoever and no hallucination.
Of course.
Yeah, I put AI into this column. And I left AI out of this talk. Just, it merits its own conversation. It's also so new, and a lot of it's in the trade secret category. But it's certainly creeping in at the corners for every one of these things, in one way or another. All right, Eric or Mike, back to you.
Sounds good. I'll share my screen again. I think you need to stop first, Tom. Maybe you just did. I clicked too soon. We're good.
To be done. Let me know.
You got it.
Okay. Look, Tyler's on here. You made it.
I did. I'm sorry I'm joining so late.
Can you well, it's East Coast hours. Are you allowed to give a talk on the NOAA stuff? Are you still working with them?
Yeah, I could do that. I could definitely talk about the satellite imagery, but not sure what exactly I would say, but I'd be happy to.
All right, I'll follow up with you later.
Sure.
Yeah, good to see you.
Okay, so yeah, definitely thank you, Tom, for all that. That was very, very awesome. I learned a lot. Thank you. So just a quick one on the previous slide. This is I imagine if you guys are here tonight, you probably know about our meetup group, but you can find it just Space Data Hackers Meetup. So that's where to join us and how to find upcoming events and sign up and register, etc. So check that out or sign up for their notifications, etc. Just a quick reminder on that. And then another plug for the Space Northwest Alliance. Mike, or do you want to comment on any of this? I'm just going to walk through.
Yeah.
And cap.
It's Space Northwest membership organization, and you can join as individuals, companies, entrepreneurs that are coming together to support Space Northwest's mission to grow and strengthen the ecosystem for space in the Pacific Northwest.
Thank you. Want to talk about volunteer opportunities?
Absolutely. So we are Always looking for folks who can help out in any of these categories. If you're the kind of person who likes seeing space events done and want to contribute in the small or in the large, reach out to info@spacenorthwest.org.
Thank you. Comments on this one?
That was last that was last month's.
Oh, sorry.
Wait, what's NASA in the hood?
Yeah,
That was June's project.
recap. That's right.
Oh.
Yeah, that was good.
From,
Jim.
yeah, Space Apps 2023.
Tom, are you going back this year? Are you going to be there in the fall for Space Apps?
Oh, me? I'm gonna try. I hopefully we'll have, you know, my son will be 2, and hopefully there'll be less bats to deal with.
So this was a previous brainstorm just about different topics for the year. So, definitely reach out to Mike or me about topics. And I appreciate Tom's comments here just about kind of, again, pulling these different threads and just following up, keeping the ball rolling on different topics and how we can go deeper. And, thank you for the breadth here, and, happy to have continued programming that's just more depth on any given topic. So thanks a lot on that.
Yeah, absolutely.
And this is a plug. I just ran into this one this week. I'm up in Skagit County area, so a couple counties north of King County and Seattle area. But this is an upcoming data hack for good. If anybody wanted to put together a team, reach out to me or Mike, or basically me. I'll drop my contact info in the chat. But upcoming data hack, if anybody wanted to do that. And then next month, so our cadence is typically on the last Thursday of the month, and I think there's some conflicting stuff tomorrow. So on this one, we're on a Wednesday, as you've noticed. So thanks for your flexibility. But I think back to the normal schedule next month, and stay tuned for topics, etc. And we're thankful for everybody's time tonight. And I'll hang out for a couple minutes if there's other additional questions, but thanks for joining.
Yeah, thanks all. And thank you so much, Tom.
Yeah, thanks
you.
everybody.
Thanks for putting this together.